Okay, so we're going to go through a couple of examples on the review guide that you got today. We're going to go through some stoichiometry ones, and then I'll go through a limiting reactant problem as well. So let's take a look at number 1. So it says calculate the atoms of iron made when 45.5 grams of potassium metal reacts with excess iron 3 nitrate. So first thing you do is write your equation. So we have potassium plus iron 3 nitrate. And this is a single replacement reaction. So we're going to get iron and potassium nitrate. And the next thing you do is balance. Okay, so we're starting out with 45.5 grams of potassium, and it's asking for atoms of iron. So in that first conversion factor, we're going to go from grams of potassium to moles of potassium. And this is just the molar mass, so we're just going to look off the periodic table for that since this is an element. Next, because we can only get from one substance to another through a mole ratio, that's what we need to do next. So what we have is moles of potassium, and what we're trying to get to is iron. And then we're going to use our coefficients here. So 3 moles of potassium, and that is 1 mole of iron. And then this last step, because we're asking for atoms, means we're going to use Avogadro's number. So 1 mole is 6.022 times 10 to the 23rd atoms. Right, and then you just need to multiply straight across, divide by the numbers that are on the bottom, and then this answer will have 3 significant figures. So 2.34 times 10 to the 23rd, and then atoms of iron. All right, let's do a limiting reactant problem. Let's take a look at number 5. Okay, so in the following problem, we have 22.5 grams of sodium hydroxide and 14.8 grams of phosphoric acid. And it's asking for what is the mass of water formed. So in this type of problem, remember that you need to do 2 conversions. You're going to convert from one reactant to our product, and then you're going to do the same thing with the second reactant. So let's start out with our 22.5 grams of sodium hydroxide. So in our first conversion factor, we're going to go from grams of sodium hydroxide to moles of sodium hydroxide. And sodium hydroxide is 40 grams per mole. That is the molar mass of sodium hydroxide. Okay, second conversion factor, we're going to do mole ratio. And we're trying to get to water here, so we're going to go to use moles of water on top, and then use our coefficients, so 3 and 3. And then our last conversion factor, because we are going to mass, that means we need molar mass of water, which is 18.02 grams per mole. Okay, multiply across the top, divide by what's on the bottom. 3 sig figs, so this much sodium hydroxide is going to give us 10.1 grams of water. Now we need to do the same thing with our phosphoric acid so that we can see how much water that is going to make. So we ended up with 14.8 grams of phosphoric acid. Again, because we're in grams, we're going to go from grams to moles. And phosphoric acid is 98 grams per mole. Okay, next step, we're going to go moles of phosphoric acid. And again, we're still going to water here, so we're going to put moles of water on top. Use your coefficients. And then that last step, just like I mentioned in class, because we're going to the same thing, that last step is going to be exactly the same as the previous conversion, because we're still going to mole or grams of water from moles of water. Okay, multiply across the top, divide by what's on the bottom, and we get 8.16 grams of water. Okay, so to determine which one is the limiting, we're looking for the least amount of water, so that's going to be our 8.16. So that's how much water is going to be formed. And then the limiting reagent is just, again, what did we start with for that 8.16 grams of water? It's our phosphoric acid. All right, last step of these types of problems is finding that excess reagent. So when you're trying to find the mass of excess reagent left over, again, remember you're starting with your limiting, and this time we're going to go from our limiting to our excess, which is our other reactant. So we're going to do, again, a mass-to-mass problem. And we've already got all of our numbers in the previous problem, so we know our molar mass. We're going to do our mole ratio, and this time we're going to go to our other reactant, which is our sodium hydroxide, and then again use your coefficients, so 3 and 1. And then last step, we're going to go to grams. Okay, multiply across the top, divide by what's on the bottom, and that gives us 18.1 grams of sodium hydroxide. So remember, this is the amount that is used. So when it says don't forget to subtract, don't forget we're going to take how much we were given and we're going to subtract out how much was used. So I'm going to take 22.5 minus 18.1, and that gives me 4.4 grams of sodium hydroxide. So that is how much is left over.